Let's say we have two samples of helium gas. One sample of helium gas is at temperature T1, and the other sample of helium gas is at temperature T2. If T2 is greater than T1, that means on average, the particles of helium gas in the second box are moving faster than the particles of helium gas in the first box. We can tell the particles in the second box are moving faster because on average, the length of these arrows indicating the velocity vector in the box on the right are longer than the length of the arrows in the first box. The equation for kinetic energy is equal to 1/2 mv squared, where m is the mass of a particle and v is the velocity of a particle. Since the gas particles in the box on the right are on average traveling faster and have higher velocities, the average kinetic energy of the particles in the box on the right is higher than the average kinetic energy for the particles in the box on the left. And so the average kinetic energy is proportional to the temperature. The higher the temperature, the higher the average kinetic energy of the particles. Instead of gases, let's look at two metal blocks made of the same material. So one of the metal blocks is at temperature T1 and the other metal block is at temperature T2. Let's say that temperature T2 is greater than T1. What that means is the particles in the metal box on the right are on average moving faster than the particles in the metal box on the left. And that means that the average kinetic energy of the particles in the box on the right is greater than the average kinetic energy in the particles in the box on the left. Also notice right now our two pieces of metal are not touching each other, so there's a little bit of space between them. Next, we bring the two objects and we put them in contact with each other. So now there are collisions between the particles that touch, and this results in the transfer of energy from the hotter object to the cooler object. So heat flows from the object at the higher temperature to the object at the lower temperature. And so the hot atoms in the metal object on the right start to move a little slower, whereas the colder atoms in the metal on the left start to move a little bit faster. And the transfer of energy continues until both objects have the same final temperature. And we say that thermal equilibrium has been reached. So here we have our two objects, and the two objects are at the same final temperature, which means we have reached thermal equilibrium. And since we've reached thermal equilibrium, there's no more flow of heat between the two objects. And since both objects are at the same final temperature, that means the average kinetic energy of the particles in both objects is now the same.